Atomic structure is also involving the understanding of isotopes. Why do we talk about isotopes? Because this was a very important discovery in the history of the atomic structure, because they realized that they had some experiments, and when they were doing the experiments, the mass didn't match, and they were thinking about, why, for example, in some cases you had this kind of mass and in some other cases you may have the other mass. So that's why, because of the development of technology and all of that, they just discovered that the atoms have also isotopes. Imagine isotopes like the twins of the elements. They are atoms of the same element with the same number of protons but different number of neutrons. When we talk about isotopes, we don't really care about the electrons. So in other words, isotopes, they have the same atomic number but different atomic mass. Here on this diagram you can see isotopes of magnesium, 3 different isotopes of magnesium. The number on the upper right here represents the atomic mass, and here the atomic number, the bottom number. As you can see, they all have the same atomic number, 12, but different atomic mass. You have 24, 25, and 26, meaning that they have different number of neutrons, as you can see right here. These isotopes, they have the same chemical properties, because if they have the same number of electrons, then they're going to have the same chemical properties. They may vary a little bit, but it's not really noticeable, because the chemical properties of the substances are due to the electrons, specifically the electrons in the outermost layer, which are called valence electrons. We're going to discuss that later in a different topic. So here, because they have the same number of electrons and the same electron configuration, we say that they share the same chemical properties. So as you can see, the difference in the number of neutrons has nothing to do with the chemical properties of the elements. When we look at the periodic table, we see that the mass of the elements is usually represented with a decimal number. This decimal number, as you can see here, is 24.305. And if you just do the average of these three, we are going to see that it is not exactly 24.3. It is because each of the isotopes exists at a different percentage. So there are some atoms, like in this case, for example, we can see that this number is closer to 24. So we can say that this isotope 2412 is the most abundant isotope, and then it has also the other 2 isotopes, but the most abundant is this one, because we can see that the average is closer to this number. So when we calculate the relative atomic mass and we see a decimal number in the periodic table, that's because they did an average of the atomic masses of the different isotopes, but taking into account the percentages of abundance of each of the isotopes. So here we can say that about 80% of all magnesium atoms, in this case, have a mass of 24. So this is as well very important for you to know that, why the atomic number, the mass number in the periodic table is often a decimal number for some elements. So it's because you have an average of the different isotopes, but also that the average is influenced by the percentage of abundance. Isotopes, they have multiple uses, and it's because many of the isotopes are radioactive. So that's as well a concept that we're gonna cover later, but maybe you have heard the concept of radioactivity. They're used for geological experiments, for example, to determine the age of rocks, which are very ancient. Also for radiocarbon dating. It's to find the age of different materials that were organic or that they had carbon in their structure. They are highly used in the detection of cancerous tumors and also in the treatment of cancer, and because of the same radiation. And they are also used in food irradiation, because a food that has been irradiated can last longer.